As we work towards Atmanirbhar Bharat, water management becomes an essential component of national self-reliance. Our nation is committed to addressing the challenges related to water scarcity, climate change, and sustainable development goals, and this commitment is deeply rooted in the scientific and technical strength of hydrology. Hydrology is not just the science of water, but it is also about ensuring water security, a fundamental pillar for economic growth, food security, and environmental sustainability. That is a prime reason as to why role of research and development in advancing hydrological sciences cannot be ignored, and the National Institute of Hydrology has been at the forefront of pioneering research in water management. With 6 specialized divisions dedicated to different aspects of hydrology, the work done at NIH holds tremendous significance for India's water future. A film showcasing these division-wise R&D facilities would not only highlight the technical expertise of the institute, but also serve as a crucial communication tool to inspire partnerships, innovation, and awareness across the nation.
At National Institute of Hydrology, Roorkee, a Center for Cryosphere and Climate Change Studies has been established as per various discussions, suggestions among various ministries, considering the need of a national level center for glacier research, studies and management. Accordingly, Honorable Minister of Jal Shakti accorded approval for establishment of Center for Cryosphere and Climate Change Studies at NIH Roorkee. This center started its functioning from May 2023. Vision of the center is to provide leadership in cryosphere and climate change studies through cutting-edge research to facilitate water resources management. Thrust areas of this center are to foster, promote and sustain a scientific culture in the snow and glacier studies, including impact of climate change. Development of a novel framework for ensemble simulations by integrating different snow, glacio, hydrological models to account the overall water balance, including snow and glacier melt runoff. Next is assessment of changes in snow glacier dynamics and their impacts on melt runoff, including impact of climate change. Collaborate with national and international research organizations, state governments and universities on snow and glacier research and organize workshops, awareness programs and training courses to provide support to the users and hydroelectric projects in safeguarding the projects, to help research groups, academia, policy makers and general public to pioneer new approaches. Long-term planning for water sustainability under climate uncertainty in downstream areas. Major studies taken up under the center include strengthening of Bhojbasa Observatory for monitoring of Gangotri Glacier for mass balance and melt runoff under climate change scenarios. Establishment of 3 new observatories for real-time monitoring of the Roorkee group of glaciers, Khatling glaciers and Milan glacier in Uttarakhand, as well as ensemble hydrological modeling, including block studies under climate change scenarios. The next study is dynamic downscaling of CMIP-6 climate projections over Himalayas and surrounding regions. Then investigations on occurrences of extreme rain events across northwest Himalayas in the state of J&K, Himachal Pradesh and Uttarakhand in relation to global atmospheric thermal and circulation changes. Impact of climate change on future water availability in Pennar and Satluj river basins. Next study is the development of countrywide inventory of springs and investigations on the hydrogeology of springs. The next study is measurement of black carbon at higher altitudes at selected locations in the Himalayan region. Then the center is also providing capacity building on hydrological aspects through trainings, workshops, and brainstorming sessions. Notable achievements of this center are development of an eastward portal for spring repository, which was recently awarded by NRSC Hyderabad. The center has also prepared a reference manual on spring mapping and also published a resource book on springs.
As per the Constitution of India, it is the responsibility of government to provide safe drinking water to all citizens. The central government has initiated several programs towards this goal and they are being implemented very effectively. However, rapid urbanization, industrial growth, agriculture runoff and changing lifestyles coupled with varying climatic conditions pose significant challenges. Large volumes of wastewater are generated and unfortunately a considerable portion of either untreated or inadequately treated before being released to rivers, lakes and groundwater systems. This not only threatens the environment but also has a serious implication for public health. Recently, a new class of threats has emerged as a new contaminants. These includes pesticides, pharmaceuticals, personal care products, trace metals and micro and nanoplastics, all of which are entering into the hydrological cycle and food chain, posing further risks. At the Environmental Hydrology Division of the National Institute of Hydrology, Roorkee, we are deeply committed to studying these challenges and developing sustainable solutions. Our team includes experts in civil engineering, agriculture engineering, environmental sciences and chemistry, all working towards advancing our understanding of environment pollutants. Our key research areas includes environmental monitoring, contaminant transport modeling, metal speciation, wastewater and solid waste treatment, river regeneration and understanding the link between water quality and human health. We also focus on environmental impact assessment and the flow requirements of aquatic ecosystems. Our division mentors the Hard Rock Regional Center in Belgavi, Karnataka and the Deltaic Regional Center in Kakinada, Andhra Pradesh. These two regional centers have made significant contribution to the hydrology of Hard Rock and Deltaic regions over the past 30 years. The HID collaborates with organizations of Central Water Commission, Central Groundwater Board and premier academic research institutions like IITs, NITs and central universities. We are contributing to national research and policy making. Our NABL accredited water quality laboratory is a state-of-art facility where we analyze a broad spectrum of water quality parameters. This includes measuring major and anions, cations, trace metals and organic compounds. Two critical instruments in our laboratory are the ion chromatograph and the inductively coupled plasma mass spectrophotometer known as ICP-MS. ICP-MS provides highly accurate detection of trace metals like arsenic, lead and mercury. These instruments enable us to build detailed models that track contaminant transport in water systems, offering invaluable data for policymakers and water managers working to improve the water quality. Notable contributions by our Environmental Hydrology Division includes patent for fluoride removal media from fly ash, contribution to the National Drought Manual 2016, development of Bureau of Indian Standards 18188-2023. It was related to the management of drinking water supply systems and service activities of water supply and wastewater systems. Input on e-flow norms for the Ganga River. Our division also completed significant studies such as environmental assessment of the Upper Ganga Basin, action research on integrated water resource management in Uttar Pradesh, the economic impact of forest fire and hydrological changes in Uttarakhand and Madhya Pradesh. Strategic plans for river regeneration in the Rispana River, studies on ionic enrichment dynamics in the Gangotri Glacier, and apart from that, we are also working on exciting ongoing projects which are externally funded with the international collaboration. Indo-Dutch DST and WO sponsored study on changing the fate of the Hindon River by evaluating the impact of agriculture on the water balance, developing a template for a cleaner Ganga River. DST sponsored study Innovation Center for Eco-Prudent Wastewater Solutions. The THDC sponsored study on development of innovative sewage treatment technology with minimum energy requirement. Then sewage sludge and MSW treatment to achieve energy self-sufficiency at sewage treatment plants. And we are also working on comprehensive evaluation of disinfection units of STPs in Ganga Basin, understanding of arsenic mobilization in groundwater of Haridwar, and formulating remediation measures and simulation of non-point source pollution processes. Then hydrological studies for the conservation of Revalsar Lake and nanotechnology enabled multifunctional materials for the detection and remediation of arsenic in contaminated water. Beyond research, we are also actively engaged in capacity building initiatives, organizing training programs on advanced water quality monitoring techniques and environmental management to equip professionals with the necessary knowledge to tackle water challenges across the country. We are committed to address the critical water contamination issues through cutting-edge technologies and nature-based solutions. We believe in the mantra of reduce, recycle and reuse to safeguard our future nation's water resources. Our goal is to ensure the pragati, the progress of our country by protecting both Prakruti, the nature, and Sanskriti, the heritage, to emerge as a Viksit Bharat. Jai Hind. Thank you all.
Groundwater is a critical water source in our country and may be considered as the lifeline of India's water supply, contributing to nearly 60% of irrigation needs, 85% of rural drinking water needs, and 50% of urban requirements. Groundwater acts as a buffer against the variability of monsoon rains. Despite the valuable nature of the resource, many parts of our country face challenges in terms of depleting water table due to over-extraction of groundwater and presence of contaminants in groundwater such as arsenic, fluoride and iron that are mainly geogenic in nature, and other contaminants such as nitrates, heavy metals, etc. that owe their origin to various human activities. In many areas such as the coastal regions, groundwater salinity poses a significant challenge. The vision of Viksit Bharat 2047 by the Government of India is a dynamic and ambitious vision that calls for comprehensive development across all sectors, and water is at the heart of this vision. Since groundwater is a vital resource for drinking water, agriculture, industrial and commercial activities, R&D on the groundwater occurrence, movement and contamination is essential to sustainably manage this important resource and ensure both water and food security as we move towards our goal of a developed nation. The Groundwater Hydrology Division at the National Institute of Hydrology plays a pivotal role in undertaking research on groundwater dynamics, recharge processes, and contaminant transport for development of effective groundwater management strategies in both alluvial deposits and hard rock aquifers. Our well-qualified and experienced scientists are actively engaged in various studies of national importance such as modeling studies of surface and groundwater resources for efficient utilization of these water resources, including conjunctive use in canal command areas, studies on augmentation of groundwater recharge through water harvesting structures and their impact on enhancing groundwater availability for subsequent use during droughts, analysis of impact of climate change on groundwater and formulation of adaptive measures to ensure water security in a changing environment, water quality studies on assessment and prevention of contamination including salinity, geogenic and emerging contaminants in groundwater and contaminant transport modeling, water resources management in semi-arid and arid areas, groundwater dynamics and saline water issues in coastal regions, development of software packages for estimation of groundwater recharge and simulation of groundwater flow. For example, the division has recently developed useful web-based hydrological modeling systems and tools such as NIH Wisdom, which is a web-based integrated catchment modeling system for decision making, and LabPro, which is a laboratory data processing system. Our state-of-the-art facilities include the Center of Excellence for Advanced Groundwater Research and the Soil Water Laboratory. These units are equipped with the latest computational facilities and sophisticated equipment, allowing us to conduct cutting-edge research and provide practical solutions to complex problems. Our division is also equipped with advanced geophysical equipment to map the subsurface, including potential aquifers and contaminated zones. In addition to conducting research, the division regularly organizes trainings on emerging topics, including groundwater flow and contaminant transport modeling, Python programming, and decision support system for water sources management. The division also organizes international conferences and seminars on groundwater. The prestigious International Groundwater Conference IGWC 2025 is scheduled to be held at NIH Roorkee in the month of March next year in 2025. Such events are designed to equip groundwater stakeholders, professionals and researchers with advanced knowledge of tools and techniques. One of our key objectives is to foster cooperation and collaboration with national and international organizations. By engaging with global partners, we aim to excel in advanced groundwater research and implement best practices for groundwater management. Our overarching goal is to ensure that groundwater resources are managed sustainably and efficiently, addressing the challenges posed by climate change, population growth, and increasing water demand.
Presence of water in soil governs plant growth, groundwater recharge, and impact of human activities on soil, vegetation, and water resources. The Soil Water Laboratory at NIH aims to study and analyze physical, chemical, and hydraulic properties of soil in the lab and in the field to advance the water resources management and environmental protection. Our laboratory is equipped with 100+ instruments, including traditional and advanced tools with cutting-edge technology, all aimed to determine various soil parameters for hydrological modeling and sustainable management of water and soil resources.
The soil hydraulic behavior is largely influenced by soil particle size distribution. The particle size analyzer in the lab is a modern laser diffraction based technique which precisely measures soil particle sizes ranging from 0.01 to 1400 microns. This helps us better understand the soil textural composition and its impact on water retention and movement. Efficient water use in irrigation hinges on understanding key soil hydraulic properties such as available water content, the amount of water plants can use for transpiration, and wilting point, the soil moisture level at which plants can no longer survive. In the lab, these critical parameters are determined using the pressure plate apparatus, a tool designed to extract soil moisture under controlled pressure, allowing us to generate accurate soil moisture retention curves for efficient irrigation planning. As the threat of heavy metal contamination in the groundwater grows, the monitoring and measurement of heavy metal contamination has become essential. The ICPOES system provides a highly sensitive and precise method for detecting and quantifying heavy metals in soil and water samples using advanced inductively coupled plasma and optical emission spectrometry. Soil Water Lab performs numerous analyses every year and has a rich archive of soil hydraulic data collected during the past 20 years. In order to reutilize and disseminate these data sets, NIH has built a web-based automated system to process and analyze lab data and disseminate the results. The system is named as LabPro, enriched with the soil data of 4,000 locations distributed across the country and being enriched by new data every day.
The Hydrological Investigations Division is one of the important divisions of the National Institute of Hydrology. The division carries out field-based and laboratory-based studies using advanced hydrological techniques, isotope techniques in particular, and other state-of-art instruments. The vision of the division is to develop methodologies and solutions for water-related issues using these advanced isotope techniques and other advanced techniques for attaining sustainable development and self-reliance in the water sector. The division has two important laboratories. The hydrological instrumentation laboratories has state-of-art instruments for measurements of hydrometeorological parameters, and the nuclear hydrology laboratory has facilities for the measurement of stable as well as radioactive isotopes. The major areas of research of the division include groundwater management studies, then surface water and groundwater interaction studies, then aquifer dynamic studies. Then we also study lakes, wetlands and reservoir, including all evaporation, water balance and sedimentation aspects of these. Then isotope fingerprinting of the various waters, of including surface water and groundwater, all types of water. Then spring studies and spring shade management studies, and in spring studies particularly we use isotope techniques for identifying the recharge areas and recharge zones of the springs. Then we also carry out studies on seawater groundwater interaction or seawater intrusion, and even inland salinity, inland groundwater salinity studies, and then submarine discharge studies. Then we also carried studies on hydrograph separation, wherein we find out what is the relative contribution of snow, glacier, groundwater or runoff water to the streams. Carried out studies on river bank filtration, and we have developed some sites for the river bank filtration. And we carry out studies on spring hydrology and spring management. And recently we have carried out a number of studies on rainwater harvesting for the NTPC and NSPCL, wherein we have given a complete rainwater harvesting strategies, plans and designs, and even including costing. So these are some of the important thrust areas that the division works on. The major achievements we can say that the division has achieved in recent times is we have developed management plans for Nainital Lake and Sukhna Lake, then development of some river bank sites, then estimation of sedimentation rate and life of many of the lakes. That is one important study that we have completed. Then we have carried out leakage and seepage studies for in the Joshimath area, as well as for Tieri Dam and Kaushalya Dam, and presently we are doing it for the Shahzad Dam in MP. Then we have mapped submarine groundwater discharge for the eastern coast of India. That study was important. And then we have also used isotope techniques to study the arrival and departure of monsoon. That was a very important study, and isotopes can be used for predicting the arrival and departure of the monsoon. Then we also developed exhaustive data on the isotope fingerprinting of India. That was a big national project. And then we developed a management plan for the Sundarban areas for controlling the salinity as well as for augmenting the fresh water. Then recently we carried out a study for the two small lakes at the Badrinath Dham, wherein we had to study what is the hydrological behavior of those lakes, and what is the source of water for the lakes. And apart from that, we have carried out a number of studies for, as I told earlier also, for NTPC related to rainwater harvesting, where we give a complete planning, designing and costing of the various rainwater harvesting structures, and which are being implemented by NTPC, and now we are doing the same for NSPCL. Currently the division is carrying out some important studies, which include hydrological and hydrogeological studies on Yamuna Basin, which is a institute level project wherein the different divisions are involved, and we will be using the isotope techniques in that study for the various hydrological components. Then another important study of the division is the surface water and interaction study for the Narmada, the whole Narmada Basin. That is another important study that we are taking. Then there is also study on meteorological drought for MP. That is one study that we are carrying out, and wherein we will find out what are the various risk zones as far as drought is concerned. And then a study on sedimentation and water quality of the Fular Lake is also going on. And we have also initiated recently a study on Wular Lake, which is a very big project sponsored by the Wular Lake Conservation and Management Authority. Then another study is important study is the impact of climate change on evapotranspiration. That is one study that the division is taking up. One more study that the division is taking up is related to the development of the rainwater harvesting strategies depending upon the various scenarios of availability of the topographic data. It's an important study that we are carrying out with IIT Kanpur, and that is related to partitioning of evapotranspiration into evaporation and transpiration. The division is also having collaboration with various international and national organizations. Under the international organizations, we are doing studies for the International Atomic Energy, IAEA Association Vienna, then World Meteorological Organization, then the British High Commission, then the British Geological Survey. So these are some of the international organizations that we are working with. And as far as national organizations are concerned, we are working with CGWB, various IITs, and then the NTPC, NSPCL, GIPCL, and NEERI, and Uttarakhand Irrigation Department, and various other organizations.
The hydrological instrumentation lab consists of various traditional as well as modern advanced hydrological investigations instruments. This is a suspended solid analyzer where in the field we can measure the sediment concentration in the water samples. So here we can collect the water. We can collect the water in the beaker, and this is the electrode of the instrument. When this is the main menu, then we can easily, once we enter the electrode deep into the water, then we can easily measure the suspended solid part available in the water sample. This is a water level, groundwater level indicator, and in this instrument the basic characteristics or the feature is we can measure the three parameters of the groundwater. First of all, we can measure the temperature of the groundwater at various depths, as well as the water level, groundwater level, and the electrical conductivity of the groundwater sample. So this is a live demonstration of the water level, where we can get those three values of temperature, electrical conductivity, and the electrical level, depth of the water. This is called as a tipping bucket type rain gauge, which measures the rainfall, amount of rainfall fall in a particular time period. This we have a depth water sampler. We can collect the water samples at various depths from any water bodies like reservoir, lake, or a pond, or even canals. We can take some water samples at different depths. which is mainly used for the collecting the identifying the water quality parameters, how the water quality is there at a different depth of in the water bodies, and also we do the collect the sample for the isotopic investigations to identify the source of water. That is called as a electrical resistivity tomography survey meter, which is mainly used for the estimating the or understanding the subsoil or a subsurface strata below the land surface. So this is the panel of the ERT survey meter, and this is the wire, and we have this is a rod. This instrument consists of the 48 rods, and where we can put these rods at a certain interval and at a fixed interval, 5 meter, 10 meter, according to the requirement. DGPS, which is mainly used for the doing the survey in the field to do the topographic survey. So topographic survey basically this is very important for the contour survey, and contour is one of the input for the hydrological modeling, where we can take the understand the topographical characteristics of the field. Then we have a echo sounder. This is also a very good instrument which can be used in the like lakes or a big ponds, where we can do the bathymetric survey. The next instrument, this is also a very good important part, like we can measure the water quality parameter. So this is called as the multi-parameter water quality sonde instrument, and this instrument we can measure this has 6 sensors, and with this instrument we can measure the major water quality parameters like the pH, EC, TC, pH, EC, temperature, TDS, ORP, chlorophyll. All these parameters in situ we can measure directly in the field, and these are basically very useful. This instrument is very useful, and immediately we can get the idea about the status of the water quality in the lakes, reservoir or the pond. Current meter mainly used for measuring the velocity in the across the channel or a small stream. So once we know the velocity, we can measure the cross sections, and we can get easily the discharge flowing through the channel or the streams easily.
This is the nuclear hydrology lab of the National Institute of Hydrology, and in this nuclear hydrology lab we have 2 units. One is the groundwater dating unit and one is our stable isotope unit. So in this groundwater dating unit, if we see the applications of this, then we can see these are for the surface water measurements and the groundwater measurements. In groundwater, these for the recharge estimation, and again identifying the source of groundwater recharge. We are identifying the recharge zones, and then the groundwater flow and groundwater velocity. And again the hydrometeorological techniques, where we are using the source of air moisture, and we are measuring the isotopes in precipitation. We are measuring we are using the isotope in ET partitioning. So these are the applications we are doing, and in addition to that we are also doing for the sediments this CGM and the lead dating. We are also using the radon for various applications. These applications are just surface water, groundwater interaction in the seawater intrusion, and to see the submarine groundwater discharge. So radon is used, but the radon half-life is since very small, so it is about 80 hours, 3.8 days. So we are taking the instrument on site and we are measuring the radon on site. While for the tritium and this carbon dating, we are bringing the samples to the lab, and then we are taking the measurements here only. Mainly we are dating for groundwater and tritium and carbon dating. Tritium dating is done up to the determination of the 50 years of the water, and more than that we are using the carbon dating. So for tritium dating, first we are using the pre-distillation of it. Then here is the tritium enrichment unit, where the tritium units are increased, and after that we are doing the post distillation work, and then we are measuring the tritium activity in the quantulus.
As we know, water is precious for life. So in case of the water, there are two important parts are there. One is the availability of water in a particular basin. If the water is sufficiently available for our need, then it's okay. And another part is the water related disasters. So in our country, a number of water related disasters are there. Like we do face glacial lake outburst flood, we do face the flash floods, then the riverine flood. So all these kinds of the floods and the water availability, the Surface Water Hydrology Division of the National Institute of Hydrology is working on all those aspects. Specifically when we talk about the glacial lake outburst flood modeling, the National Institute of Hydrology has started this work around 14 or 15 years back. So we do carry out a number of hydrological studies related to the glacial lake outburst flood modeling. We have carried out these studies for the NHPC, NTPC and various state departments, then the TSDC. Similarly, we do carry out the dam break and emergency action plan modeling. So dam break and emergency action plan we have carried out for Gujarat, Madhya Pradesh, we are carrying out for the Chhattisgarh and various other states, and then also for the NHPC. A number of dam break studies still we are continuing. The National Institute of Hydrology has initially carried out 2 pilot basin studies for the Uttarakhand region. Then recently we are carrying out floodplain zoning studies for the Ganga river basin, specifically from the Unnao to Balia, and then the Ramganga. The Surface Water Hydrology Division has prepared the guidelines with NDMA. So these guidelines basically talk about how the glacial lake can be monitored, and then what are the disaster management plan can be made. We are also carrying out a number of studies which covers particularly the how much flood basically is arriving at a particular site if the glacial lake outburst takes place. Then what is the travel time of the glacial lake outburst flood at a particular reach. Then how much will be the spread of the flood, and then what will be the depth at a particular place. So these are some of the important part through the glacial lake outburst flood modeling we do find out. So basically if you see, the velocity and the depth of the water plays a very important role, especially when we talk about the dam break flood modeling. So the combination of the depth and velocity basically tells us which area is the vulnerable and most disastrous in nature. So this way we classify the whole area. Then we plan the emergency action plan, and we do prepare the notification charts, especially for the dam authorities as well as for the administrator. Very recently, National Institute of Hydrology also carried out some of the important studies for the Ayodhya region. We have carried out a study which covers the blue infrastructure of a residential colony of the Awas Vikas, and Surface Water Hydrology Division is also carrying out safe grade elevation studies for the nuclear power plants and then the thermal power plants. Any plant like the nuclear power plant or the thermal power plant is near the river site, and then if a flood comes over there, then how much safe elevation we have to keep for the plant. So through the hydrodynamic studies we find out that what is the safest elevation where we can put our plant. Surface Water Hydrology Division has also developed a number of softwares. One of the software is the design flood estimation. So these design floods may be the 100 years flood, 50 years flood, or the SPF or the PMF. Through these softwares, design flood estimation software, one can use these software and one can find out the design flood of a particular project site. Surface Water Hydrology Division also maintaining one observatory. We measure various hydrological variables like the rainfall, temperature, humidity, wind speed, and we are disseminating this information. Those are demanding these things. So basically these observations keeps us giving the information about how the climate of the Roorkee is varying. So we are solving various problems which now the country is facing. So these problems are related to the infrastructural development, economical development. Apart from that, we also provide trainings to different students, engineers, practicing engineers of different state and central agencies, and the faculty members, so that the knowledge what the Surface Water Hydrology Division has gained in the last 30 or 40 years, we try to disseminate these kinds of the knowledge to various researchers as well as for the practicing engineers, so that they can utilize these knowledge and use these in their work.
India is characterized by significant spatial and temporal variability in water availability, creating a mismatch between supply and demand. This often leads to deficits and at times extreme disasters such as floods, droughts, soil erosion and sedimentation in reservoirs. Water stress is rising especially in large parts of our country. This is driven by several factors such as rapid population growth, expanding irrigation demands, industrialization, urbanization and of course climate change. Despite these challenges, a major roadblock remains the lack of accessible and reliable hydrological databases. Many water source projects are planned in isolation without the integration needed for optimal use and environmental sustainability. This fragmented approach further aggravates water-related problems. To deal with spatial and temporal distribution of water and other challenges, Water Resource Systems Division has well-qualified team of scientists and staffs. Our division's mission is to provide feasible scientific solutions to India's water problems by developing methodologies for integrated and optimal water resource management on a basin-wide scale. We are committed to understanding the hydrological process more deeply, such as evapotranspiration, soil moisture, groundwater recharge, and surface runoff. Our division has initiated experimental hydrology projects in critical regions of the country, including the Central Himalaya like Envel catchment located in Uttarakhand, the Western Himalaya located in Leh, Ladakh, and in the Eastern Himalaya, Tista Basin located in Sikkim. We have established state-of-the-art hydrological field observatories equipped with advanced automated instruments like automatic weather stations and automatic water level recorders to collect precise and continuous data. Our involvement in national programs like National Hydrology Project NHP, National Mission for the Sustaining the Himalayan Ecosystem NAMSHI, and the National Mission on Himalayan Studies NMHS has been instrumental in expanding our reach and impact. These projects aim to improve water resource management and ensure the sustainability of our fragile ecosystems, especially in the Himalayan regions. Our division is involved in system studies for river linking projects such as Mahanadi Godavari link, Ken Betwa link and Farakka Sundarban link. We work to model and understand snow, glaciers and permafrost dynamics, which are critical in regions dependent on seasonal snowmelt. Additionally, we are leveraging advanced tools such as remote sensing and GIS to improve water source planning and management while developing user-friendly software such as NH Recipe, NH Basin to perform reservoir simulation and water source planning. Our remote sensing and GIS laboratory is a critical asset in this regard. It is equipped with advanced softwares like ArcGIS, ERDAS Imagine and ENVI, which allow us to carry out a wide range of hydrological and water source studies. The laboratory also houses high-end equipment including an A0 color track smart F image scanner, A0 size Canon color plotter and a laser color printer, allowing us to analyze and visualize data at a high resolution. We also maintain an extensive collection of topographic maps and satellite imagery, enabling us to conduct detailed research and provide robust recommendations for water management and strategies. Water Resource Systems Division is committed to find long-term sustainable solutions to India's water challenges. Through research, technological innovation and field-based studies, we aim to contribute to a future where water resources are managed efficiently and equitably. We are confident that with continued efforts, we can ensure the optimal and sustainable use of water resources in India.
भारत में दुनिया के कुल फ्रेश वाटर का सिर्फ 4% ही है हमारे एक बड़े भूभाग को पानी की कमी से जूझना पड़ रहा है। कई जगहों पर पानी का स्तर लगातार गिर रहा है। क्लाइमेट चेंज का ये संकट को और गहरा रहा और साथियों, इस सब के बावजूद ये भारत ही है जो अपने साथ साथ पूरे विश्व के लिए इन चुनौतियों के समाधान खोज सकता है।